Hi, welcome. I thought I'll prepare this little document to help you guys out with the thought process for the coming uh, engineering communications assignment. Okay. Apart from, but before going through this process, I'd like to point out something on the bright space that you should have a look at it. Okay. Remember this engineering communication assignment tab. Once we are in there, scroll down. Do do have a look at these short little videos. They are quite well done on dimension guidelines, showing you how to tap out dimensions from Inventor. Okay, then there is this cutting plane, how to draw a cutting plane. That was something which I didn't have time to cover in the last lesson. Do take a look at this video and then try it out yourselves. I will review it on Wednesday before the test, right? And I will make sure that everybody knows how to do this. Okay. We can skip this creating local section. That's not necessary at all. Um, and what I'm going to go through is I'm going to go through the thought process on how the CA3 example 1 IPT is being handled and how you get the the end results of creating the 2D document. All right. So as you scroll down, you realize that these are all the parts, and one of these parts will be assigned to you for the assignment on that day, and the amount of time that we have to complete this whole assignment is 3 hours. Okay, it's 3 hours. All right. Without further ado, let's go back to the PowerPoint slide. So what is the thought process? Now, when you first open up the part on Inventor, right? Inventor. So when you first open up the part on Inventor, okay, you will see this component, and when you press the shift button and center mouse button, and you could rotate it, and you can look at it from all views and angles. Okay, you can click on the cube to see the front view, the top view, and you can also look at it from the right view. Now, if it's rotated in the wrong orientation, you just move your mouse over to the rotating arrows over here, and it will rotate the views for you. Okay. Now, as you retrieve your part out, study the part. Okay, so that's the first thought process. Study the part and image how this part was created feature by feature. Okay. Um, from a typical component, identify out where is the main body. And for me, this main body is usually the base, the vertical portion of the body is like an L bracket, and this slope feature over here tangent to a circular curve section. Right, so that's how you go about doing it. You identify, and then you identify the rest of the features. So in your mind, you need to break down this part into little features. Okay, and then you start off with the main body and you ask yourself, what are the dimensions that you need to create this part, meaning the length, the width, the height, right? And after you're done with that and you've extracted those dimensions out, you then move on to the next feature. And when you move on to the next feature, you identify where is this feature located with respect to the main body. Okay, and followed by its individual dimensions which are required to create it. Again, it could be a width, it could be a height, it could be a radius. Right? So it depends largely on the feature itself. It's never certain that it is always a length, a width, and a height. Okay, so that's the thought process that we go through. So I'm going to walk through with you. The example that we have looks like this, right? And I identify this out as the main body. The second portion that I see is a boss, right? Which is like a circular feature that is being extruded out like an extra appendix, okay, that's coming out. And then the second feature is a web, and then there is a second boss. Next, you could create the threaded hole. There's a threaded hole here. It's a blind hole. And then there is a counter bore hole within this first boss, right? So the main body looks like that. So what happens is that in your mind, when you are handling your this part here, you sort of need to look beyond these little protrusions and try to visualize in your mind, how do I go about creating the uh, first block, okay, the first body, and this is the first body, right? Then from this body, you go on to tap out all your dimensions, okay? The reason why they look like they are like crisscrossing is because they are viewed from different planes. What do I mean by that? Let me go over here. If I were to view from the front view, I can extract these dimensions, okay? Then if I were to rotate and I were to view from the end view, I would see the width, right? So what happens is that for my okay, let me delete the rest of the dimensions so that it looks clearer, not so messy, right? I needed the 75. That would be a perfect opportunity. So let's say I want to create the base, which is, let's say I want to create this, and what are the dimensions that I need to know to create this, okay? So if I go to Inventor, the dimensions that I'll need to create this, of course, that I'll click on the dimension here. All right. Now, if you were to look in the video, they chose ISO, but for me personally, I prefer ASME in millimeters. Uh, and all I need to do is I click the radius. If I'm okay with this plan view, yeah, I click one here, and this is R24. Okay. So to create this base is basically a rectangle. So I need to know its length, which is 96. All right, from the back all the way to the front, and then the width is 70, and the height of it is 25. Okay, the height of it is 25 over here. Then once I've drawn the base, then I ask myself, oh, how high is this thing and how do I go about drawing it? Now this part here is a little bit complicated. How this part was created is it has a circular feature here, so you actually need to know what is the radius of this feature. Okay, it's R20, and you also need to know how high is this R20 with respect to the bottom of this base. So what you can do is you click the dimension, click on the outer radius, and then it looks like it's giving you a radius, right? But don't worry about it. You're not done yet until you do a second click on the outside region. Move your mouse to the bottom line, okay? Or you can even rotate and click on the bottom face. And what happens is that it drags out, okay? So the center of the boss to the bottom surface is 75 millimeters. And if I want it to be, so now it's projected in this view, right? The front view. But if I don't want it to be projected in the front view because it doesn't accurately reflect it, right? Or it doesn't reflect it in the clearest possible manner. The clearest is actually on the right view. So what I do is I right click, select annotation plane, and I select the surface, any surface that is facing the right view. So I can choose this surface, or this surface, okay? Now don't choose the curved surface, don't choose the slanting surface, because then your dimension will be at a slope. So you click this surface and I click somewhere here. So when I pull over to the right view, I'm able to create this part. Okay, now some of you are wondering, how is this part created, right? So what happens is that you need to know the width of the part, okay? So you need to know the width of the part, and then from the height of the part you could draw a circle. Then from the corner at the bottom you draw a line, and the line is tangent to the circle of R20. And that's how you create this base. You can first draw out this base in your 2D AutoCAD, right? Now the next feature, this part of the slide shows the amount of dimensions that I've extracted out, okay? And then the next feature is the first boss that protrudes out further. Okay. And I went on to find more dimensions, like dimension 16, right, from here that comes out. And for this case, right, because this particular boss has already been pre-located from the main body, it is coaxial, or it is exactly the same, share the same center as the curve from the main body, right? I need not specify the location of its dimension at all, right? It is because it is already identified earlier. But however, I do need to state how thick it is, because in the earlier body there is no thickness that states the first boss thickness. Okay. Then the next feature is the web that comes out. And so what happens is that I go and I create the dimensions for the web, and the thickness is 12 and the bottom of the width is 32. So how do I go about doing that? Same thing. It was deleted earlier on, right? And I can click on this line and this line, and I have the dimension 12. Okay, this is dimension 12. Then I can click this line here, and I want it to be on this surface. So I right click. Excuse me, sorry, let me try again. I click this point and this point, so it goes to the point, and then I right click. I would say I'll choose this surface. Okay, and the bottom width of the rib is 32 millimeters. Okay, so these are the two dimensions that are required for me to create the rib. Next is the boss that comes up over here, and the dimensions that are required for the boss, um, this boss, right? uh, Now, this is the interesting part. Okay, the dimension that I have here is 78. All right. Now, earlier on, when we make measurements, we took reference. That means we always take measurements from the back of the part to the front. Okay, and what you can do is that you should dimension this, that when you click on the cylinder, right, it will give you a radius, but what you do is you move to the back, you click on the back surface, and what it does is that it will give you the distance of the center of that curved surface to that back surface that you just click, and this is 78, right? And that's at the center of the boss. So I always try to make my dimensions with reference to one feature. uh, doing this would make your drawing a little bit neater. Okay, it in from the manufacturing point of view, it will make it easier for the machinist, because when he clamps your workpiece down and he does his machining, he will always take reference from one face. If you are not restricted, you can actually do this. You can actually click from this surface to this surface, right? And it's 18 millimeters, right? However, if the design principle is, I won't fault you if you do this. I won't fault you to do this, but in the future, if you were to do something like that, it will just make the life of the machinist a little bit more difficult. That's all, because then he has to remember to take reference from another edge. Okay, so whenever you can, try to take reference from a common point, right? Like the back surface and the bottom surface. Okay, so like for example, this rib, if you don't do it this way, if you want to dimension your rib to the back surface, you could as well, but for me, I chose the rib to be from this edge to this edge because Hang on for a second, changing the annotation plane. Because the rib feature actually ends at this point. Okay, so then it is with reference to the back of the wall, which is 24 millimeters, right? So that's how the thought process goes for this particular feature. Now, the next feature that I'm creating is the counter ball, right? And for the counter ball, um, what I do is that I'm going to show you this function where you extract out whole information. I mean, as in HOLE, the information of the holes, and the data will present itself this way. And what does this mean? It means that there is a hole that is diameter 18, and it's a true hole. That means it goes all the way through, and it's followed by a counter bore at diameter 28 and it's 16 millimeters deep. So from this surface to this surface here is 16 millimeters, right? How do I go about extracting this data? This was not shown last week, so I'm going to show you now. You move your mouse over. Instead of clicking on dimension, you click on hole or threaded nodes, okay? And then what you do is you move your mouse to the hole feature and you click on it, okay? Then this one comes out, right? And you click OK. So why do this? So if, by doing this in one click, you can extract out the information of the entire whole, and you wouldn't have to bother with finding out dimension by dimension what this is. Like for example, doing this, then after that, okay, then finding this dimension, right? Then after that, clicking OK, and then clicking another dimension and selecting these two surface, right? So it's, you can see it's 16 millimeters deep, right? Uh, by 28 millimeters, the outer diameter, the counter bore diameter, and then the true hole is 18 millimeters. So it saves you less clicks, okay? But when you are presenting it in your 2D drawing, you cannot write out this text, right? The module coordinator wants you to actually to spell out the dimensions for the counter bore, meaning to say that it should look something like he'll want you to present it something like this, right? Diameter 18 for the true hole, and then diameter 28 for the counter bore, and the depth is 16. And the reason why he wants you to do this is to make you appreciate how a section view could allow you to easily um, show what the countable feature is and could allow you to put dimensions to it and clear so that it can clearly be represented, right? Likewise for the threaded holes, you can also or you should also dimension it accordingly, where you state that this is M16, right? But you do not need to dimension the inner diameter, all right, which is the blind hole, okay? And the blind hole, the threaded hole is up to 20 millimeters. The blind hole is drilled to 28 millimeters. Okay, how do you create all these hole features? This was taught last term, so please look it up and revise. Now, going to the threaded hole, okay, again we use the hole features, and this one will show you that it's a diameter 14 uh, diameter 14, you drill all the way to 28 deep, right? And then after that you have a M16, 2-6H is the thread with thread data, and it is to be threaded to 20 millimeters deep, okay? So how is this represented in your answers? It should look like it should look like this, okay? M16, uh, 20, right? Threaded to 20 and then drilled to 28. Okay. Then Let's see. Going back to Inventor. Now, if you were to use the whole thread node feature, and when I click on it, right, and I move it out, you realize that hey, it doesn't show my blind hole, right? So how do I go about doing it? So what happens is that when you click on it, and when you click it, you have this uh, table that comes up that allows you whether you want to accept it, yes or no, not okay. You need to click on this little window here. It says edit the whole node. So when you click on it, select tab drill and you click OK, so that you know that the blind hole is 28 millimeters, right? If not, you may actually have to click this, and then you need to find where the blind hole ends. And then you extract out the data, right, which is 28. So it's a lot more tedious, okay, if you were to do things like that. We're extracting it feature by feature. Okay, for holes, it is best if you use this annotation tab, annotation function, where it just directly tells you the feature, the whole feature, what it is, and then if you were to click on it, you could even get more information out of it. Okay, all right. So that's how this whole thing is being approached. um, and the last thing, after you've completed all your drawing, I remember I mentioned this, um, do check your section view if it's correct, and we can do it in the view. Click on half section, and the half section, where do you click next? You go to the origin and you select the XY plane, okay, and then you click OK, the green tick, and you'll see the section. Okay, so you'll be able to check the section view of what it looks like. All right, now other than the half section, uh, you could also check whether you got your hidden lines correct. Okay, how do you go about doing it? If you go to the top view, and under the view, you have the visual styles. You change the visual styles to shaded with hidden lines, and your hidden lines will pop out. Okay, so you can see from your top view that these are the hidden lines that exist from the counter board. All right, and the hidden lines that exist for the web. Okay, so when you're doing your drawing and you're doing out your hidden lines and you're not sure whether is it correct or wrong, check using Inventor. Okay, if you go to the front view, you will be able to see the hidden lines as well. Okay, so if the lines of the dimensions are starting to bother you and make a mess of it, then you could delete it. Okay, you could delete it, or you could save as a different part name, and you can open up the fresh part that you downloaded earlier. And then when you click on the view edges, then you can see there the blind hole is here, the threaded hole is here, the counter ball feature is here, right? So all the hidden features can be shown, right? So this assignment may look very daunting, but actually with the help of Inventor, a lot of the answers are already there. You only need to know where to click it, so that it reveals itself to you, and you can check and verify your answers and make sure that you get everything right. Okay, with that, I end my explanation on the thought process on how to go about extracting information and then putting and to so that you can create your AutoCAD 3D drawing. Sorry, 2D drawing. All right, with that, thank you very much.